All right. This is a little bit of information about our week 12 materials. We have an exam on MIDI and synthesis on week 12, and we have a project, our final project for the third module of this class. So I'd like to talk through those two things here. Well, let's talk first about the exam. The exam will be administered as we've been doing in the past, where you'll attend the class during your normal group session. You'll download a file, a Word document that you'll then complete your answers in the lab at your normal computer. It's of course a closed book exam, no access to other things on the internet. Just that document, please, and the D2L website for you to upload it to. So when you complete the exam, you'll resave the document with your last name as the file name and upload it to the Module 3 Group 1 or Group 2 exam Dropbox that you'll see on D2L. And that's the same way we've been doing them in the past. So what you can expect on that exam is similar to what we've done for the last exam, where you have answers to complete and on these two main subjects. And these are drawn from your last three study guides from weeks 9, 10, and 11 on synthesis, the basic synthesis model, the oscillator, filter, and amplifier. And remember that we used shapes to determine the oscillator, the filter, and the amplifier in our discussion of synthesis. What these things all do: the oscillator generates a waveform at a certain frequency. The filter shapes your timbre, and where we have filters of different types. Know your different filter types and be able to describe what they do. And then we have our amplifiers, amplifier module, which amplifies the sound, basically creates the articulation of the sound through the ADSR module. That adjusts the overall level of your sound. Modulation is when we use an LFO to change certain parts of our synthesis model. So be able to describe what an LFO stands for. An LFO is a low frequency oscillator. And when connected to these components, it changes the pitch, it changes the cutoff frequency or the timbre of our filter, and it changes the overall output level over time. So the modulation is basically determined by the LFO, or the low frequency oscillator. And it is when it is connected to these modules of the synthesis model, it changes those parameters. Also know your 5 essential waveforms: sine, square, sawtooth, etc., noise, those sorts of waveforms. And know the difference between the noise and periodic waveform, basically being able to describe how they are different. How a periodic waveform, like a sine wave, has a regular pattern. Noise, the wave shape, does not have a regular pattern, and therefore it does not have a discernible pitch. Know the difference and be able to describe the difference between synthesis and sampling. Remember that synthesis is a sound generated from the ground up using an algorithm or a predetermined wave shape. Sampling is the loading of a sound file into the space of the oscillator in the synthesis model, and you trigger that sample by pressing a key. Your amplitude envelope and your ADSR module are ways in which we control the articulation of a sound, and know what the ADSR stands for: attack, decay, sustain, and release. In the MIDI realm, also know what MIDI stands for: musical instrument digital interface, and what it does, its primary function, the history, how it was developed in the 1980s, in 1982 to be exact, and what also it was developed with: the personal computer and the digital synthesizer. Know the difference between a MIDI module and a MIDI controller. Remember that a MIDI controller is basically an empty keyboard. It has knobs and sliders and buttons and keys that allows you to interface with a sound-making module of some type. And a module is something that holds sounds but does not have a keyboard. Know how to connect MIDI components together with connections and cables. These days, we use a USB cable to connect MIDI gear to a computer. Know your MIDI note numbers. For instance, the middle C of a MIDI controller is MIDI note number 60. And we then can determine an octave above by adding 12 to 60. So the C above middle C will be 72. The C below middle C will be 48, and so on. And that has to do with the MIDI data range. Remember that in MIDI, everything is determined between a spectrum of 0 to 127. So other MIDI parameters are also behaving within that range. Note on and off. If the note is on, it is at 127. If it is off, it is at 0. The velocity. High velocity sounds have a brighter timbre and are louder. Lower velocity sounds are quieter and darker. Pitch bend has a continuation from 0 to 127. The sustain pedal from 0 to 127. Modulation wheel also from 0 to 127. So these MIDI parameters are also possible to control in a MIDI sequencer. Speaking of MIDI sequencer, we record, edit, playback MIDI information in a MIDI sequencer. An example of a MIDI sequencer is GarageBand or Ableton Live, or any other program that allows you to record, edit, and play back MIDI information. Another example of a MIDI sequencer is a music notation program like Sibelius or MUS score. A MIDI interface is something that you can use to connect MIDI gear to your computer, right? It allows you to connect MIDI gear to a computer. MIDI interfaces are not necessarily as common because more and more MIDI equipment does not use the MIDI in and out cables. But a MIDI interface is still important to understand how it helps to connect multiple MIDI instruments to a computer. Quantizing in this instance is the practice of correcting the rhythmic values of your MIDI notes so that they align with a tempo grid, and be able to know what a plug-in instrument is, or a software synthesizer. Basically, that it is a plug-in that is holding synthesizer sounds that you control with a MIDI keyboard. Those are the topics that are going to be on our exam, and those are things that we've been talking about the last few weeks, and those are also a part of your study guide for study guides from Module 3. So to turn to the project, and I'll discuss this at the top of our exam when you show up for your exam, when you log into our meeting. But at this point, we're kind of combining all the things that we've demonstrated in the last 3 projects. And we're putting them together in a larger project that has a longer duration. So we're looking at a 3 to 5 minute song in GarageBand that is essentially a MIDI sequenced tune. It should have at least 5 unique instruments at any given time. So your piece should have 5 unique instruments. You don't need to use them at all the time, but you're selecting between at least 5 instruments throughout the song. At least one should be a drum sequence. At least one sample should be used in a repeated rhythmic manner. Okay, that does not necessarily count as an instrument, but it is, since we don't have a sampler instrument necessarily, but it is a sound that we're going to be used as a layer. All tracks must be quantized and fit into the rhythmic tempo grid of your sequence. So it doesn't have to adhere to the standard 120 beats per minute. You can change that tempo. Remember, there's a tempo adjustment timeline that you can use to make it slow down and speed up if you want to. But every track should use automation and to control panning, volume, and other audio effects in your plugins. Your work must be balanced and mastered the best you can. And most importantly, your song should sound like a coordinated musical idea. It should have an organization to it. It should have a verse, chorus, or a verse, or an ABA structure. So you're going to create so if we were shooting for 3 minutes, you can imagine it having a first minute, a second minute, and a third minute. That first and third minute can be related to each other with a middle section that is a different sort of texture. So that your song has an organization to it and has sections. And most importantly, you must title your song. And that gives it a little bit more meaning than just a project. So upload your MP3 to the Dropbox folder. Share it as we normally have been sharing it. Do not upload a GarageBand file, please. And as a note, you are welcome to use portions of previous projects from this module in this project. However, take care to make them match the song that you are creating. So if you want to use a snippet of your second project for the middle section and a snippet for your third project for the first section or something to that effect, you're welcome to do that. But please make sure that it's edited so that it sounds like one continuous project and that it all seems to go together. Okay, so that we're creating a musical object. So 5 unique instruments. They should all have effects of some sort on them. They should all have some sort of automation so that they are coming to life, and we've talked about how to do that. You're also including a sampled sound that is used in a rhythmic manner. All these things don't necessarily have to happen all at the same time, but you are organizing them into a song structure that has an A, B, A format, or a verse, chorus, verse, or something to that effect. You're titling it, you're bouncing it to MP3, and then you're uploading it to the Dropbox. So have fun with this project. I look forward to seeing your work in this regard. You can take some creative liberties with this, but as long as it adheres to these requirements, you are in good shape. So if you have any questions about this project or the exam, you're welcome to contact me and we can set up a time to meet about it. Otherwise, I will reiterate these requirements before our exam, at the top of our exam, and I can address questions then as well. We'll see you then.